Hi, my name is Audrey Suh, and this is my Lab 2 report. A brief introduction to this lab. The goal for this lab is to make a more accurate estimate of the charge of the two tapes. Instead of modeling each tape as a single point charge, multiple charges are modeled along the tapes. Some concepts we discuss in this lab are charges, electric fields and forces, Newton's second law, and superposition. A notable difference from Lab 1 is that we don't model the tapes as singular point charges. We now model the tapes as multiple point charges to receive a more accurate estimate of the charge of the tapes. For data collection, when I collected some data, I found that the mass of the tape was 0.0002 kilograms, the length of the tape was 0.2 meters, the width of the tape was 0.18 meters, and the distance between the two tapes when held near each other was 0.021 meters. These are some calculations from Lab 1. First, we calculated the force of gravity by multiplying the mass and the gravitational constant. From there, we were able to get that the force of gravity was 0.00196 newtons. Since the tape was in suspension, we assumed that the sum of the vertical forces acting on the tape was equal to 0. Thus, we set the electric force equal to the gravitational force, and from there calculated the charge, which was 9.8 e to the negative 9 coulombs. This is an example code from Lab 1. As you can see, both tapes are modeled as point charges, and the forces acting in the vertical direction are the gravitational and electric force. This is the code from Lab 2 using the cue found from Lab 1. As you can see, the electric force, which is the white arrow, is significantly smaller than the gravitational force, which is the yellow arrow. Once I was able to find a new cue, as you can see, the two arrows are now equal to each other. Something else to note is that the green arrows, which are the arrows representing the electric field, aren't pointing in just the y direction, but they also have a bit pointing in the x direction. This is an example code that allowed us to iterate through to create multiple point charges. As you can see, they utilize for loops. Similarly, this is a section of the code that allowed us to iterate through to create multiple electric field arrows, which also utilize for loops. Some comparisons between the codes. So I found out that when I used the old Q value from Lab 1 in the Lab 2 code, the electric force was not equal to the gravitational force. In fact, it was much smaller. After trial and error, I found that the new Q was 2.328 e to the negative 8 coulombs versus the old charge, which was 9.8 e to the negative 9 coulombs. As you can see, it is much larger than the original charge that I found in Lab 1. These are some questions asked for Lab 2. What was the magnitude of the charge on one piece of tape? The new magnitude of the charge was 2.32 e to the negative 8 coulombs. And what are some assumptions that we made in this lab? Well, first we ignored air resistance on a moving object, and second we assumed that each U-tape had about the same amount of charge, which was evenly distributed along the length of the tape. Something to notice is that compared to Lab 1, we no longer assume that each tape is modeled as a point charge. Some further questions. If we had modeled each of the tapes as a single point charge, like in the previous lab, what would have happened? Well, if we had modeled each of the tapes as a single point charge like the previous lab, we would have gathered that the charge on the tapes would be 9.8 e to the negative 9 coulombs, a value that is significantly smaller than our line charge value, which was 2.32 e to the negative 8 coulombs. So why do these estimates differ? And which value is more likely to be closer to the real value, and why? These estimates differ because in the line charge value, we assume that there are multiple point charges spread across the tape as opposed to a singular point charge. The point charge also estimates that there is only a force acting in the y direction, while the line charge indicates that there are forces acting in both the x and y directions, thus creating a different ultimate charge. The value that is closer to the real value is the line charge estimate because it models more realistically the electric force. Thank you very much for listening to my presentation.